Examples of Fourier series. Let me examples on. Hello, dear students. Series. Let me take first example. The first example is obtain the Fourier series of f of x is equal to pi minus x divided by 2 in x lies in between 0 to 2 pi, hence deduce that 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus so on is equal to pi divided by 4. Now this is an example they have given. You have to find the Fourier series and of the given function pi minus x divided by 2 in the interval 0 to 2 pi. Hence deduce this condition, this series. Okay. First what you have to do to deduce this series, you need to find the Fourier series. And how to start the example of this type is that each and every example of Fourier series you start like this, that is the Fourier series, Fourier series of f of x having period 2 pi is given by like this: f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity bn sin nx. Let me call this as equation 1. This series is called as trigonometric series and we are assuming it is now Fourier series. Now presently it is now is a trigonometric series. After getting these constants a0, an, bn, these are known as now Fourier constants. Now you need to find these three and substitute these three values in this equation 1. You will get the Fourier series. How to start the next example? How to find this a0? Let me start. A0 is equal to, you can write here as I given, where a0 is equal to 1 divided by pi integration c to c plus 2 pi as in the general formula, but at presently the given interval is 0 to 2 pi, so you have to take 0 to 2 pi only. Okay, then function f of x with respect to dx. Similarly, an is equal to 1 divided by pi integration 0 to 2 pi f of x into cos nx with respect to dx. Similarly, for bn is equal to 1 divided by pi integration 0 to 2 pi f of x into sin nx with respect to dx. So this is about the formulas a0, an, bn. These are known as Fourier constant. Now let me start to find a0, an, bn. Now let me start for a0. A0 is equal to 1 divided by 5 as I have taken 0 to 2 pi function f of x with respect to dx. Okay. Now substitute f of x. F of x is given here, so use here 1 divided by pi integration 0 to 2 pi f of x is pi minus x divided by 2 with respect to dx. Okay. Now integrate 1 divided by pi as it is. So integration 0 to 2 pi. So pi minus x into dx. What I am going to take, I will take this constant 1 by 2 outside. I will write 2 here. Now I can integrate 1 divided by 2 pi, right? Then integration of pi into 1 is there with respect to dx, it becomes pi x, minus integration of x is x square divided by 2, and limits are 0 to 2 pi. Now apply upper limit and lower limit. Constant as it is, apply upper limit, it become 2 pi, here on x is 2, pi as it is here 2, it becomes 2 pi square. Then minus, if you apply here, it becomes 4 pi square, 4 pi square divided by 2 as it is. And lower limit is 0, it becomes a 0 now, don't go for this one. Okay, then minus 0 you can write here, upper limit minus lower limit. Then further 1 divided by 2 pi as it is, then bracket this 2 pi square as it is, minus 2 1s are 2 2s are again 2 pi square, bracket 2 pi square minus 2 pi square, it become 1 divided by 2 pi, 2 pi into 0. So therefore the value of a naught is become 0. Finally you got a naught is equal to 0. Okay, now let me go for calculation of an. So an is equal to formula is 1 divided by pi integration 0 to 2 pi f of x into cos nx with respect to dx is equal to 1 divided by pi as it is, integration 0 to 2 pi as it is, f of x, again you have to use the same function, pi minus x divided by 2 into cos nx with respect to dx. Okay, now as I told you, I used to take the constant outside 2 pi, I have taken 2 outside. So integration 0 to 2 pi, pi minus x as it is, cos nx with respect to dx. Now after this you just leave this constant and you observe and don't see the limits, only you see integration pi minus x into cos nx, product of two function, apply Bernoulli's rule. Now you remember how the Bernoulli's rule is very important here. Okay, so let me apply Bernoulli's. This is algebraic first function, this is second function, keeping this constant as it is, 1 divided by 2 pi as it is. Now let me go for first function as it is. Then integration of cos nx is sin nx divided by n, minus rule says differentiation of first function, pi is constant 0, minus as it is x differentiation is 1, so minus 1. Then again integration of this one, sin nx is minus cos nx divided by n, this n it become n square, bracket here it close. Why? Because differentiation of minus 1 becomes 0, so applying limit 0 to 2 pi. And you remember that whenever this, when you apply 2 pi inside here, the value becomes 0, this becomes 0. Okay, so therefore as you know that because of from the formula which I have given in the last the set of formulas, 6 to 7 formulas, in that if you apply 2 pi it becomes a 0, when you apply 0 also sin 0 0 becomes, so if you apply 2 pi wherever x is there, it becomes sin 2n pi, so it becomes 0, so this becomes totally 0. So therefore 1 divided by 2 pi constant, remembering this only, only remainder is this one, so minus into minus plus, plus into minus minus, so I will take minus sign outside here. Then n square is constant, I will take outside. What is remaining? Only remaining cos nx, applying limit 0 to 2 pi. Okay, so this is the remaining part. Now keep this minus 1 divided by 2 n square pi as it is. Now apply upper limit, cos n as it is, x value is 2 pi, 2n pi, minus when you apply this here it become cos 0. As you know that minus 1 divided by 2n square pi bracket, when you go for this again a formula, the value of this becomes a 1. So as we know that cos 2n pi is equal to cos 0 is equal to total, this is value 1, this is value 1. As you know that cos 0 is 1, okay, cos 0 is 1, so therefore the value of this become 1 minus 1, 1 minus 1. So therefore finally minus 1 divided by 2n square pi, it become a 0. So therefore the value of this term becomes a 0. So therefore an is also become a 0. An also becomes a 0. Okay, now let us move to find the last Fourier constant Bn. Now you have calculated a naught, you got 0, an you got 0. Now let me calculate bn. So to calculate bn, let me start. Okay, let me start this one. Bn is equal to 1 divided by pi integration 0 to 2 pi f of x, same function, and here it becomes a sin nx with respect to dx. Now substitute 1 by pi as it is, integration 0 to 2 pi as it is. F of x is nothing but pi minus x divided by 2 into cos nx with respect to dx. Okay, now let me move further. I used to take constant 2 outside, let me take 2 pi outside. Integration 0 to 2 pi, remaining pi minus x with into sin nx with respect to dx. Again it looks like a product of two function, apply Bernoulli's rule. So 1 divided by 2 pi. Okay, so first function as it is pi minus x, integration of sin is minus cos nx divided by n, and rule says minus, then again a differentiation of this one is minus 1, then again integration of this function is minus, and as it is cos, integration is sin nx divided by n, already n is the square, then further you will not get, apply 0 to 2 pi. As I told you, when you apply this 0 and 2 pi in sine function becomes 0 by using formula. Okay, so this becomes 0, only remaining this term. So I used to take like this, n outside, minus n outside, minus 1 divided by 2n pi I will take outside. Then what is remaining, bracket pi minus x into cos nx, applying limit 0 to pi. Okay, 2 pi. Now apply minus 1 divided by 2n pi as it is, apply upper limit, pi minus here, when you apply 2 pi here, pi minus 2 pi minus pi, apply this, it become cos 2n pi, keep it as it is, then minus, when you apply 0 only pi remains, pi, when you apply this cos 0 it becomes. Okay, as we know that is minus pi as it is, cos 2n pi is 1, minus pi as it is, cos 0 is 1. So therefore the value minus 1 divided by 2n pi, bracket minus pi minus 2 pi. So see here 2 pi minus into minus plus, so answer becomes 1 divided by n. The value of bn is 1 divided by n. Okay, so finally we got a naught, an and bn. After getting these all values, substitute all these values. I will write here, put a naught, an and bn in equation 1. So equation 1 is like this, f of x is equal to a naught by 2 a naught is 0, uh, a naught is 0 and divided by 2 it becomes a 0, plus b naught is an is 0, don't write it, only write down summation n from 1 to infinity bn value is 1 by n, then sin nx. So this is your required Fourier series, which is required Fourier series of the function f of x is equal to pi minus x divided by 2. This is the required Fourier series. Now the example is still not at over, because you have to deduce one series. Or to deduce that series, what you have to do is that exactly I am going to write here that further to deduce the required series, we put x is equal to pi by 2. Now the question arises, why pi by 2? The question arises, why we have to put x is equal to pi by 2 to get that exactly series? No, I will tell you the important note. I will in the Fourier series, okay, Fourier series 2, you can call this one as 2. Okay, so the question arises that to deduce that particular series, I am substituting x is equal to pi by 2. So understand very concept that I used to take one important note. The note is like this, that note, if the series in sine, if the series in cosine, you will get here sine. So particularly this example I got in a sine. So in that, if the sine function comes, you need to substitute x is equal to pi by 2. You will get the required series. Definitely you will get the required series whenever if you get a Fourier series of sine function, sine nx, then you have to substitute x is equal to pi by 2 only. That is the compulsory. Then next, if the series you will get in cosine, the cosine series, if you substitute the value of x is equal to 0 or x is equal to 2 pi or pi, you will get the required series there. Okay, note, I will write here note at x is equal to 0 or 2 pi or x is equal to pi RHS of the Fourier series becomes 0. You observe here, if you substitute these three values here, it becomes 0. See here, if you substitute x is equal to 0, sine 0, series eliminated. Then if you substitute 2 pi, sine 2 n pi is 0. If you substitute pi, so that is sine n pi 0. So all these three values, the series will become a 0. So that's why to get the series, put x is equal to pi by 2. As I told you that if you see a sine series, you put x is equal to pi by 2, you will get the required series. If you substitute x is equal to, if you get a cosine, a Fourier series as cosine, use or put x is equal to 0, 2 pi, x is equal to pi, you will get the required series. Okay, so therefore hence we try here, x is equal to pi by 2, which belongs to in the interval 0 to 2 pi only. It is not more than that. You have to take in the interval, given interval, that is 0 to 2 pi. Okay, now let me deduce that series. Okay, so you put in LHS also, you have to put in a RHS also. So therefore f of pi by 2 is equal to summation n from 1 to infinity 1 divided by n sine n pi divided by 2. Okay, so here f of x is what? Pi minus x divided by 2 is equal to, okay, so apply summation, put n is equal to 1 2 3, you will get like this, 1 divided by, so put 1 divided by 1, n is equal to 1, here also 1, so sine pi by 2 you will get. Then further plus, go for next, n is equal to 2, 1 by 2, put here sine 2 pi divided by 2, then put again 1 divided by 3, sine 3 pi by 2, it will continue, plus 1 divided by 4, 1 divided by 4, sine 4 pi divided by 2, plus 1 divided by 5, sine 5 pi divided by 2, it will continue further. Okay, so here it is, pi minus pi by 2 is pi by 2, pi by 2 divided by 2 is equal to 1 divided by 1, sine 90, and 90 is 1, this becomes 1, this 2 get cancelled, sine pi 0 plus 0, go for next one. Okay, sine 3 pi by 2 minus 1 minus 3, so minus 1 by 3, this becomes minus 1, okay, then plus, this becomes 0, then plus, this becomes a plus 1 by 5, this is plus 1, so it becomes plus 1, so it will continue further, then plus 0 again, then minus 1 by 7 into 1, or plus 1, here plus 1, here minus, here plus 1, here minus 1, you can get, so therefore 1, this gone, plus minus 1 by 3 plus 1 by 5, this minus 1 by 7, plus it will continue, so denominator, numerator of denominator is denominator, it becomes pi by 4, so hence we got 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus so on, you will get answer as pi by 4, which is a required series. Okay, so this is an example where you can find the Fourier series, very easy example. First you have to assume that a trigonometric series as Fourier series, in that you need to calculate, or you have to find the Fourier constants a naught, an, pn by using Euler's formula. Okay, after that whatever the deduction they have given, so you have to deduce according to that. Okay, what the Fourier series you will get, that depends on the Fourier series. To deduce any term or any series, the Fourier series is depend. Okay, if you get sine series, if you get a sine function, you have to put x is equal to pi by 2. If you get a cosine series, put x is equal to 0, pi or 2 pi, right? Thank you. So we'll continue in the next example. Okay.